Okay. Last time I gave you the what we call that pop quiz, right? Pop quiz. So the answer for that pop quiz is this one. Actually, I take it from question 3, final exam for semester. What semester is this? Semester 1, 18-19. It's quite tough. Okay, this one. Question 3. So this is part B. Basically, you're going to have something like this in your final exam. They will give you like 5 questions. Question number this one, question 3, and then they have A, and then they have part B. The one I give you is part B. This one, part B. Can you see my screen? Is it clear?
Yes,
or not
madam.
clear? Yeah.
Clear.
And then they give you marks here. So you can actually estimate where you want to save your marks. Make sure you do you need to at least know how to answer the first part, the first question, because sometimes they will relate with the second question. In this one, the part B here, question 3, part B, the I and 2, I and this one, number 1 and number 2 here, they are not related because they give you 2 signals, signal for voltage and signal for current. Even though they are not related, but they are useful for part 3, not part 3, this number 3, because they ask you to evaluate whether the voltage signals or the current signals are lagging or leading, right? So for this part, if you look at here, yes, I give you something like this. Voltage equal to 8 sine 20t plus 30, and then plus 4 cosine of 20t. Okay, so what do we mean here is that you need to use your calculator, yes, but before you use your calculator, you need to know how to transform this into what we call that Phasor form, right? Do you still remember what is Phasor form? Anyone? How many category of Phasor? Phasor. Phasor.
3.
Yeah, 3. If you don't remember that, you can go back to your this one, your slide. You have this, right? Yeah, and this one, rectangular, polar, and exponential. How you want to solve that? You use these 3. Not all 3. You just use either one because you want to save time, right? If you look at the question, it's so many in the final exam. So if you look at here, first we have that rectangular. What is the second one?
Polar.
Polar. Okay. Third.
Exponential.
Exponent.
Yeah, very good. Okay, so this is Phasor. And then you look at here. This is sine, this is cosine. Obviously, we cannot just add up these 2. So what we need to do is to first convert this sine into cosine, right? So if you want to convert that, you use this is sine, this is cosine, right? So you need to minus with 90 degree, the 30 degree here. So you minus with 90 degree, 30 minus 90, you get negative 60. That's why you have here negative 60. And what is 8? 8 is the amplitude of the signal. Okay, so that one is the first part, but we haven't touched on this side. And if you look at here, this is 20t, right? It's actually written as this one with 0 degree. So you know that here it should be with a 0 degree. And 4 there, 4 is the amplitude. So you just add these 2 and you will get the answer of something like this. 10.583. This one you just need to use calculator. This part you use calculator. Okay. All right. For the second part, this is cosine, and this is also cosine. But if you look at here, this is with a negative, right? Negative cosine. Sometimes you can just you can convert it to plus cosine, but if you do not want it, then still okay. This one negative cosine, so if you want to convert it, you have to plus with 180 degree, because one quadrant is 90 degree. So you know that this is plus 180 degree. So if you use directly -5 as the amplitude, then you just get this one, and the -40 is this part. And then 3 with 10 degree is the first part. Let me change color. The 3 here and the 10 degree. So you have this and this, right? So you just plus with use your calculator for all this. But you need to be careful with this part, because why? You have the negative side here. How to use calculator then? You insert the 3 with 10 degree first. If you wonder how to use calculator, you can go to Google Classroom, and then you have the what we call that video link I shared. And then for this one, the negative side, you use bracket minus a bracket of 5. And this one, even inside here also, you need to be careful. You use bracket. So 5, bracket of -40 degree, and the whole bracket here. And minus, okay? But if your calculator can just directly use without bracket, then you go ahead. But for me, I always do something like this so that I don't do any error in the calculation. Okay, so the last part, when you have these two answers, let me change the color. Okay, when I have these two answer, then I need to convert back to this form, right? Because the question I ask you to use this form. What do I mean here is that if you look at here, this is small letters, right? And this one is the capital letter. Capital letter is for polar form. Phasor form. But for this one, this is directly with respect to the time, because we want to check on the which one is leading and lagging, right? So if you want to compare, make sure this cosine and also this one angular frequency also same. So if these two are same, then you can compare two signals. All right. And then how to draw this, it depends on you. If you want to follow my steps like this, you can use these steps. But if you do not want, maybe you learn it from your math class, you can draw the complex plane. So up to you. Okay, as long as the answer is correct, then go ahead. Right. So if you look at here, the -40 should be on the right side. Okay. And the positive 103 is on the left side. So you start from here, and then maybe I change the color again. Can you see yellow? And this is -40 degree. So it starts from here to here. So these two plus together, you will get 144. Right. So which one is leading? Current or voltage?
Current.
Very good. Current is leading.
Correct.
Right? Okay, I think majority of you do understand this chapter. But if you look at this, the previous question, they are, I think somehow, yeah, because they have 5 questions here. Question 4 and question 5. You cannot actually follow directly to this question. I actually cannot show you this answer script. This is from me, but I think it's crucial because you guys are going to take this. But please bear in mind, if I didn't share, that means the other instructors also didn't share the thing. So better not to share. Okay. Oh, they also have the part 3C because in the final exam you have 3 hours. But for you guys, for this not this semester, the previous semester, I mean before the MCO, so they have 3 hours with 5 questions. The face-to-face class, 5 questions. Yours is just 2.5 hours, if I'm not mistaken, if they didn't change the thing. So 2.5 hours with 4 questions and plus 0.5 hours to submission, I think. Yeah, the submission time. So, but usually this one, you cannot see the 0.5 minutes here. So, yeah, just keep in mind that you need to use 2.5 hours to answer 4 questions. So basically you need to time like maybe 30 minutes for each question. 30 minutes, okay? So if you guys always drag the time, make sure that you need to practice more. Okay. Any question before we move to our class? Ada?
InsyaAllah no.
Tak ada Okay. Okay, if you look at here, this is our break, right? We just finished Idul Fitri, Alhamdulillah. And then Idul Fitri break. And then this is 19 today class. But next week, the same day, we have Vesak Day. I'm not sure our UIA is having holiday or not, but I put it a Vesak Day here. I think it's a holiday. But if we don't have that holiday, then we have the normal class lah. So now it's already week number. We lose 1 week, so I assume next week will be week 12. So just follow this one. 19 and today and next week Monday, and then Saturday, if this is holiday, then we go to week 13. So I hope week 13 we are already in the last chapter, chapter 7. Chapter 7 means for your slide, I put lecture 7, something like that. Okay. So week 12, for week 12 here, I will give you some videos. Actually, I already gave you in the Google Classroom, right? Did I or not? Did you check it or not? Not check. Did you watch it? Or you confused or something? This one. Oh, this is all the. Okay, I think all the videos. Ada tak videos? Okay, here. You go to classwork, and then all the videos. And here, the calculator tutorial here. These two calculator, Casio, the old one and the new one. And then I have the capacitor derivation, capacitor, inductor, and resistor derivation. I hope you already done that because we are going to enter that today. And then the rest for this one, chapter 9, current divider, examples, and the mesh and nodal. And yeah, this mesh and nodal are all in the last part of our chapter. I haven't give you the latest one because we still have the like Thevenin, all the methods that we learned from chapter 4, right? So we need to reapply that for our chapter 6 here. Chapter 6 coming from your chapter 9 and chapter 10. from your textbook. Okay. All right. Any question? You guys okay, right? I hope you guys okay. Finish your midterm? Huh? Are you okay? Finish your midterm or you still have some other subjects? Midterm for that.
Should be finished.
Okay, alhamdulillah. I hope so, eh? So we go to our the last part we stop. Okay. Did you try this or not?
Madam,
Madam.
for A,
A,
how
done.
do you, no, I mean, how do you put the square root part?
Oh, square root part. This is the one I explained you from here, right? Okay, the square root. The one I mentioned to you, if you can, I think I asked you guys to use calculator first. And then if you cannot use calculator, then you use math operation for complex number. Right? Or not?
Yes.
Yes, okay, good. So if you look at here, so you manage up until where? Up until inside here? This one?
I just tried it. I got the one in the brackets, but not the square root part.
Okay, so for the square root here, if you maybe you, what do you get for the inside bracket of before the square root? Let me check. Do I have the answer or not? Sekejap, eh. What do you get? Do you get this? Negative 15.5 plus J 13.668. By the way, please keep at least 3 figures. Okay. And then you have that square root, right? Square root coming from this one. So you can use the square root 2. And then with some bracket here, this one, with face divide by 2. Okay. So what we mean here, you need to convert rectangular form into polar form. So what do you get for this part? You get this? Do you get this?
Is that Madam?
Check your calculator. Or maybe you get this one, 20.666 with 138. Yes, the one I get here is actually using the normal calculation, the math operation. Because this negative 41.4 is actually coming from, if you draw the plane, this one, the complex plane here, this is the negative side, right? So this is 41.4 degree, and the positive side should be this part. So you want this one, 138.59. But if you use calculator, I think they directly show you this. So you just use this. Okay. I hope everyone get or maybe at least try this, because if you try this using calculator, you know that you sometimes you make mistake at rectangular form or maybe at this polar form here. So try to avoid that mistake. By what? By practicing using the calculator. Okay. So if you look at here, sister, do you get the same answer or not?
Yes.
Okay. So if you have a square root, what do you need to do? Obviously you cannot use calculator. So what should you do? You use the math operation. So you use that. This is 20.666 square root of this. And then for the phase, you divide by 2. 138.59 divided by 2. Then you will get the answer. Okay. So usually the answer will be in polar form. So this one is equal to this. I think they already give you. If you have it in polar form, then it's okay. You can still convert it back to rectangular. You will get the same answer. Right? What about the B, part B? Anybody here have maybe difficulty somewhere? I think this one just a normal one. No need to worry. Anybody here try this one? Okay, I give you time to do this. Maybe not now, later. But please let me know if you cannot get this. Right? Because I think this is quite straightforward. If you didn't try, then you cannot see which part you cannot use or you do some error. So if you do have some error, then we can discuss later. Please let me know. Okay, so this part, yeah, cosine. Cosine is easier than the sine. So you better use cosine function for this study. And then this part is to show you how to get that polar form. So if you have the cosine, you should use the amplitude and also the phase. That's why you have amplitude and the phase. And then if you have the sine, you use the this conversion, right? Cosine, and this is sine, and this is minus 90 degree. So that's why you need to minus the phase part with negative 90 degree. Okay, and then from sine, you can convert it to cosine. Then the rest should be same. This one and this one same. Okay, this one is a polar form. You want to convert it to polar form. And this one exponential form. And this part rectangular form. Because you have that cosine and sine. Later on, you're going to remove this one. So you can get rectangular form after that. So, but better to use calculator so that you save your time. Don't use the what we call that, the normal one. But if you want, but sometimes the question give you, you don't need to use calculator for that question because it's quite easy to use a complex plane. Like this one, a complex plane of imaginary axis and the real axis, right? So if you look at the equivalent expression down here, they give you 1. What can you say about this 1? Is it a real or imaginary?
Real.
Real.
Real. If you write down in terms of rectangular form, you have a real part plus j for imaginary axis. So I just put it like this. Okay. So 1 plus 0. Okay. So this one is a real part, but if you want to draw on the plane here, this one should be something at this axis, right? Because this is number 1, a real part. And we do not have any face, right? Okay. Or we can put it, this is a rectangular form. In polar form, this can be written like this, right? With 0 degree. Because there's no face different or no face here. It is at the real axis. So 0 degree. Okay. And then what about the exponential? Can you guess? Exponential? Yes, we need to have E. What is in front here? And what is that J with something here? Can you guess? You need the amplitude, right? So in front should be amplitude, something like this, same as this one. So you have the this is the amplitude, and then this is a phase, right? So if you want to write down in terms of exponential here, then this is the amplitude, and this is the theta or the phase. Okay, so you get me, right? So this is the amplitude, and the J with what? A 0 degree, right? Because we don't have that. So basically E exponential of 0, you should get 0. So no need to write down in terms of exponential, right? do you get me or not? Do we want some activity here? Okay, I give you the second one. One with 135 degree. How you draw this on the plane? Okay, starting from here, the real axis, right? And then you know that this is 90 degree, right? Okay. And up until 135. So 90 plus something will be equal to 135. So what is that? This degree? 45, right? Right?
Yes.
Okay, very good. This is J, imaginary axis. And then how to write down this in terms of rectangular form? Without using calculator. Okay, for the x-axis. X-axis is this one. And you know that this is, the amplitude is 1, right? So you can write down 1 here. And then because this is on this side, so you can use a cosine or sine. A cosine or sine. Brothers and sisters, are you okay? Yes.
Sine.
Yes, cosine. Okay, 45 degree. But is it a negative side or positive side?
Negative.
Negative, okay, because it's on the left side, left quadrant here. So basically you can also write down in terms of maybe negative square root 2 over 2 or negative 0.7007. So what about y? Going up here is positive, going down here is negative.
Positive. Positive.
Positive. Positive. What is the amplitude?
When?
Yes, very good. And then this is a sine or cosine? Or what is? Yes, 45 degree, right? So you just use the calculator and you will get this, or 0.707. And since we want to write down in terms of rectangular form, then you can write down maybe this or what? Negative 1 over square root 2 plus j 1 over square root 2. Up to you. But usually, yeah, we need this number, decimal numbers, right? So plus j 0.7, something like this. Okay, what about exponential? Exponential? J with what? How to write this? What is it in front and what is at the back here? We need this, right? As an amplitude. So this one should be 1, and then J with 135 degree. Betul tak? Is it correct?
Yes.
Okay, what about EJ 270? this part. EJ 270 degree.
The
If you
magnitude is
go in,
what?
Amplitude one.
Amplitude is what?
Okay. So you can draw on this plane because this is 90, 180, and 270. So it is going down here, right? This is J plane or imaginary plane, and this is a real axis. Do we have any real axis here? This is 1 in front, right? So we can write this is 1. Do we have any real axis here for this?
No.
No. So 0 real axis. If you want to write down in terms of rectangular form, then this one 0 plus J. What is that on the left side? Is it a plus or minus?
Minus.
Minus, right? So 0 minus J. Or you don't need to write the 0, so it's only equal to negative J. Okay, so this is equal to negative J. And then what about polar form? How to write polar form? Polar form have this one. And what is the angle? Face, the face. You need this, right? And this. So what is the amplitude?
One.
1. Negative 170.
Yeah, very good. Okay. So what about number 4? Rectangular form. Okay. If you want to draw on the complex plane, where is that negative 180 degree? If you start from here, then this is plus, right? But if you start from here, this is a negative side. So this is 90 degree, and you can just end up until here. And this one is this one. Okay. Is this clear or not? Right. All right. So what is rectangular form for this? Do we have imaginary axis or not?
No.
No. So plus J0, right? But what is the real axis?
Negative one.
Is it a negative? All of you agree negative or is it positive? Obviously, right? If you have it on the right side, this is positive. On the left side, a negative, right? So negative 1. Okay, very good. And then what about the exponential part? You need the exponential, okay. But what about in front here? Amplitude.
Negative.
Negative 1. If you put it
1.
using negative 1, you need to also consider on this part, the face part. You have to have J 180 degree. So if you want to follow exactly from the polar, then you have here 1 with J negative J 180 degree. But you can use your calculator. Do you get the same answer or not? With negative 1 EJ 180 degree. Okay, you're supposed to get the same answer. Even you can convert it into negative 1 here or the polar from here. You will get all the same answer. Okay. Can I leave this one to you or should we discuss all? Or I give you the Jamboard. I give you Jamboard, okay. Oh, ada orang baru masuk lah. What about if I give you the Jamboard? Right? Ada dua dah. Okay, use this link. Oops. Bahaya. So where's the Jamboard? Okay, here. Bagus. Alright, masuk semua. Let's check with this. Sorry if I use Malay word for all international students. I hope you guys learn some of the Malay words. What is the latest trend for Malay word for Palestine issue? Or you guys know, right?
Is it the
Yes.
busy
Koyak.
Israel?
Koyak.
Okay.
They
Yeah.
use like reverse engineering thing.
Very
Like
good.
the Israelis will read the tweets about Palestine.
MashaAllah. That's right. Yeah, we need to give our consent to do this because they are our brothers. Okay. So even we have students from Palestine. Right. Okay. Can you see my Jamboard here? Okay, who wants to try this one? The E negative J 90 degree. And maybe another volunteer 145 degree, another one 180 degree, and another, the last one with 90 degree. You can try it here, or here. Anywhere you like. You use the complex plane. Draw this one. And then it's better to draw on this because it will be easy to you guys. Okay. Any volunteer? Okay, very good. By the way, write down which one you want to answer so that your friends will not repeat. Okay, good. Okay, with 90 degree. Okay, this is correct. And what is this one in terms of rectangular? All right. Don't wait for your friends here. You can just draw one with 45 degree. Okay, good. 0 minus. Yeah, very good. Please do not use I because we want to differentiate between current and imaginary axis. Yeah, even though your calculator will straight away show you that this is the negative I, but you use negative J. Okay, very good. This is correct. Okay, good. Yes. Okay, number 5 done. Number 6, one with 45 degree. Yes, good. 45 degree, this is correct. But this one, all right. Okay, so what is in terms of X and Y, the rectangular form? Do not leave like this. You need to write down in terms of rectangular form. X plus G imaginary axis, real plus imaginary. Write down. Okay, 180 degree. Yes, this is correct. How to write down in terms of rectangular form? 180 degrees. Okay. 1 with 90 degree. Yes, this is correct. Okay, good. Rectangular form. You should draw this part. This is 1. And you should draw this part. Okay. This is 1. Okay, very good. It's a positive and positive here. Okay, good. Okay, rectangular. Rectangular. You can draw this. Scenery area. Okay. 1 plus. Are you sure? Are you sure this is 1 plus something? Okay, for this one, yes, correct. But do you have it negative or positive? The 180 degree here. Okay, let me check here. Do we have real axis? Okay. This one. Are we in the positive or negative side? This is positive, right? And this is negative. This one, yes, correct. This one, correct. Okay, we don't have any real axis for 90 degree here. Yes, very good. And this is a plus. Okay, a plus. All right, very good. Kosong pula dah. Okay, good. This is correct. What about exponential? This one done. Done. Okay. Last one. This one. Exponential. How to write this in exponential form? You need the amplitude. Okay, dah. So we have 1 exponential j 180 degree. Yes, correct. Okay, I think all of you know how to do this. This one is just to avoid from using calculator, because sometimes you have a very easy number to use the complex plane. Like this one, you know that 1 is actually stand for the real axis. And then 1, if you have that 1, you don't have any degree at that 1. So you know in polar form, this one 1 with 0 degree. So straight away, without using calculator, you can actually save your time, and then you just use this part, right? Because later on in your chapter, this chapter and also next chapter, you're going to have you will come across with something like this. They will show you something like this is the voltage source, and this resistor, maybe this is capacitor, and then some inductor, and then they will give you this part with maybe sometimes they write down in terms of this. Sometimes they just put the value 5. So you can actually understand it well from this complex plane. Okay, let's look back at our slide. Any question before we move to this? Ada? Tak ada?
No.
Good. Right. This part actually I have to teach you this one first sebab dia punya slide ni very not organized. So but I think you guys already know how to write down in terms of this is a sinusoidal. How do you know sinusoid? This is small letter, right? Sometimes they put it small letter like this, sometimes with respect to time. But you need to know that this is actually with respect to time because there's T there. Okay, so in Phasor form, you can write down this one convert to Phasor form, it becomes a capital letter, right? This I here, small letter becomes capital letter with some bar there. And then you have the amplitude from here, sits, and then the phase, negative 40 degree, right? Anyone here wants to try? Tak payahlah try. Sebab over here dia dah tunjuk. And this one negative sign, then you can plus, if you put it like this is sine, this is cosine, then this is negative sign, right? So plus 90 degree. So obviously you have a V here with capital letter. And then you have 4 cosine, cosine. I better not to draw like this, just write down 50 plus 90 degree. So you get the answer. Okay, 4 with 140 degree. But it's actually this one, V, respect to time, then 4 cosine 30t plus 50 plus 90 degree. That's why you get this 140. Okay. What about this one? You need to find sinusoid form. This is the Phasor form. Okay. So this one they bold it, bold the letter V and I. But you need to know that in sinusoidal, this one will become small letter with respect to time. And then you have negative here. This is amplitude, and then this is a cosine, then some angular frequency time with 30 degree phase. Okay. And what about current? Current, but this one, how to solve this one? Any idea? If we expand this, we have a J5, right? And then minus J square 12. Do you agree here or you confused? Or maybe you put it in different way. You use calculator. Please use your calculator. J into 5 minus J12. What do you get? You're supposed to get the same. Okay, use your calculator. What do you get? Do you get the same answer like this one? Sekejap, boleh back tak? Tak boleh. Okay, tak apa. Saya tulis balik. Okay, J5 and then minus J squared 12. This one you just multiply directly. And then if you look at here, this is quite, why we have the square, right? You don't like square. So what should you do? From your math class, I think you guys know this one, right? Do you?
Or the negative one.
Yeah, this is familiar, right?
Yes.
Okay.
Yes.
You substitute this negative one into this part. And let me change the color, this part, right? Then this one will become J5, oops, J5 with negative 1. It is not negative 1. This one should be put it here. So negative J square is actually 1, right? Plus 1. So plus 1, no need to write down. It's J5 plus 12, something like this. So rearrange back, it's supposed to be real first, real number, and then imaginary. Okay. And then if you want to use your calculator, then you can get the answer in terms of polar form. What is this? Or if you want to use your math operation, then this is 5 square plus 12 square, and with tangent, inverse tangent of 5 with 12 degree. Do you know what I mean here? This is coming from the real axis is 12, right? This is 12, and the imaginary is 5. So this is your apa panggil ni? This eye, correct? This eye face. Okay, so you use theta, and this theta actually, if you want to find it, then you need to use inverse tangent. So that's why you have inverse tangent 5 divided by 12. And then what about this amplitude? You need to use this square plus this square and the square root. That's why you get this. Then you can actually get the answer. Okay, but yeah, please do not waste your time. You can just use your calculator, but you need to understand what does it mean by this and how do you get that without your calculator, so you can get. And then if you want to write down in terms of with respect to time, then you need the amplitude 13, cosine, this is angular frequency with this 22 degree, right? Is it okay?
Yes.
Alhamdulillah.
Madam?
Yes.
Oh, okay, no, because the first question too, since it's negative, is it necessary to change to positive cos?
Can? Also can. No problem. So if
Alright.
this is a positive cos, this is you can just plus with 180 degree. Okay. Then this one becomes 10 cosine WT plus 30. If you give me both answer, I accept. No problem. 30 plus 180. 210, right? Okay. Answer? Yeah, answer they give it in terms of cos. Because throughout your study, you're going to use it in terms of cosine. Okay. Saya lupa ini. Thank you. Okay, now this part. This one I think already explained. This part, relationship, we call this one integral differential equation. Sometimes they call it integral differential equation. As long as they have integration and also differentiation. So you have these two. What is this number one? Number one, just want to show you that this is with respect to time. The signal V with respect to time. If you observe here, this is a small letter, right? And if you want to convert this, sometimes usually they put it in terms of amplitude, Vm, and the cosine V signal. Okay, so if you want to write down in terms of Phasor form, you have a capital V here. Okay, because I cannot bold this, that's why I put bar here. And then what is V? The second one, V for the second one is your magnitude, amplitude. Okay, amplitude. So this is Vm. And then with the theta V, it should be theta V, right? Because I want to follow this and this. So this is how you write down in terms of this. Integral differential is that they actually apply if you have a differentiation in your equation. Let's say this is respect to signal V, dV dt. And then you can actually just replace this thing with a J angular frequency of V bar here, something like this. And then the second one, I know this one almost difficult to check which and which. But this is actually V amplitude. This is a V bar. Because why? Because we want to convert this into this, right? So it's supposed to be capital letter with bar. And then the second one, you have the integration. Integration of V, small letter here, with respect to time. Then you want to replace it with a V bar divided by J omega, because this one is supposed to be converted into capital letter in Phasor form. This is all Phasor form. Oops, Phasor. And this is with respect to time. Okay. Maybe later on show you here for voltage, same to the current, it's supposed to have the same method. Right. Use something like this. If you found in the equation, they have integration like this, differentiation like this, and then they give you the long signals like this. Then sometimes this. So what should you do? You need to understand that there's a better way to answer this using the integral differential equation. Right. So for this, how to solve on the right side first? What is it in Phasor form or polar form? Where is it in the polar form? Any? Okay. Any suggestion?
50.
Okay. Wait.
75 degrees.
75.
Yeah, very good.
75
All right. Okay, what about 4i, number 1? What should we do? For I. Please look at here. This is a small letter. So what should you do? To change it to Phasor. Small letter always with respect to time. Sometimes they didn't write down in terms of t here. Time, no. Then what should you do? How to convert it into Phasor? For
Degree 0.
0? No. For I bar. A straight conversion. Okay. 4 with I bar and then plus 8. What is it? Differentiation with respect to I dt. If you look at this table. Which one is a differentiation? Integral form. Differentiation plus integration. Number 1, number 2, or number 3?
Number
3.
3.
Which one? Yes,
Three.
number 3. So what is that? What is that?
I
I, okay,
I
divide
over
by
JT
J omega, right? This one omega. Okay, so I over J omega. But what is our omega? If you look at here.
2.
so
Omega is a 2 radian per second. Still remember, right? Which one is omega? It is here, right? The 2 per second. Okay. So you can just replace the omega here with 2. Let me just replace this one with 2. Okay. And then minus 3 di dt. Which one is that di dt? Number 1, number 2, or number 3?
2
2. Okay. So what is that? How to write down in terms of this?
J2
J2.
J2
I.
I, capital letter, right?
Yes.
Okay. So J, 2, capital letter. Something like this. Okay. Now, can we simplify this? Because we have, let me use pointer. We have I here, and I here. And then we have 8. You can divide by 2. And then 3 with 2, right? So can we simplify that?
Yes.
Yes. So 4 plus 8 minus 2. We have 4 divided by J. And then that I, we just put it all outside. And then we have minus 6 J, right? But usually we write down J first. So J sits with I there. And then can we simplify the middle part here? How to simplify the middle part here? This one. 4 divided by J. How to solve this?
Negative
Times
J.
with J.
Yes. You can use the one you learn from math. Maybe this one, right? J square negative 1. So since we have ito ko sa'yo. Sekejap. Time with J. Time with J, then everything will be times with J, right? But if we substitute, can we do the substitute of this? Can we or we cannot? Let me put it here. Negative J square equal to plus 1. Okay. And if you look at in front here, let me change it. If we have in front here a plus 1, can we substitute this plus 1 with this one? If you like to do this. Else you need to multiply by J everything. So susah juga tu. Up to you. So if we substitute this, okay, let me substitute this. So 4 plus 1 here becomes negative J square. And then this is 4 over J. And then minus J6. And this is all into I, right? Eyeball. And then 50 with 75 degree. Okay. And then this part and this part you can cancel out. And you will have 4 minus J4 minus J6. Basically you have J 10, right? And then you have the I bar. Equal to 50, 75 degree divided by 4 minus J10. And you can use your calculator, right? Do you agree or you confused? Maybe you confused here. Do you confuse here? This is just bring this part into here in front. And then you have a plus 1, right? So you just replace a plus 1 with a negative J square. That's why we have a negative J square here. The whole thing here. So I just put the green color here. Right? Is it clear or confused somewhere? Am I connected or lost connection?
Yes, you are connected.
Connected.
Right. So you guys try to digest, right? Okay, tak apa. Now what is the answer for this? Let me write down in terms of polar form. This one becomes, do you get the same answer as me? If you use your calculator, 4.642, 143.2 degree. You get this?
Yes, madam.
Alhamdulillah. Okay. And then how to write down in terms of, because the question asks you to use, determine the current IT, the small letter, with respect to time. This as an amplitude, right? So, and then this one should be 2, and then the phase is 143.2 degree. Okay, don't forget the unit, ampere, right? Is it clear, or do you have any question somewhere? If you use integral differential equation, you will save time because you do not need to do the integration here, the differentiation here. It's lengthy work if you use that. Right.
Wait, madam, so we can leave it as polar form, is it?
Polar also, this is a polar, right? Or this one,
Or
the
is
final
it
answer.
better?
Better to put it in polar form so that you can directly convert it into this, this with respect to time. Okay, easier than rectangular form. Is that what you asked me, or I get it wrong?
No,
Or do you ask me? Okay. Okay. Hi. Okay. Since we already done that polar form, just to familiarize you guys with polar, you need to know how to use your calculator. By now, you need to know how to use your calculator, the complex form. Okay. If you have problem, please go through again and again from my video, the how to use calculator for complex form. If not, I hope you guys are okay with that. Then we go through this resistor. This one already derived in your in the video shown. I hope also you guys check on the video. And this part, if you look at here for resistor, how to draw this? It should be same, right? The current and voltage, they are same plane. So they have the same theta, right? For V, and same theta for current. So they have no phase difference. Okay, no phase difference. And then what about the capacitor? Which one is leading? Still remember which one is leading? I think the explanation in the video are quite clear. So if you look at here, okay, for the inductor, current is lagging, right? Current is lagging, and for capacitor, current is leading. Okay, for the resistor, current and voltage, they are on the same phase, no phase difference. But for the inductor and capacitor, they have 90-degree phase difference, 90-degree and 90-degree. Okay. And then if you look at this, this is directly voltage equal to IR. But for this part, this is voltage equal to IR. But this one we didn't call it as a R here. We call it as an impedance of inductor. And for this part, we call it impedance of capacitor. Okay. So later on, you will see that. Saya rasa ada kat sini kot. Okay, something like this. Tapi I don't like to be written 1/j omega c. So how you do this in terms of negative part? What is the equation? For capacitor? Negative?
J omega C.
Negative what? Omega c. Or divide by omega c. Which one? If you maybe you memorize this one, but you need to convert J omega c Then how to convert this? You need to use a J square if you like. Since this is a +1, and you know that this is a J square equal to -1, right? And you want it to be a +1 there. So you just replace with a +1 with a negative J square and divide by J omega C. And this one you can just remove. And what left is the negative J over omega C. So I hope you guys please do not remember this 1 over J omega C, but please use the negative J divided by omega C. This one better. Why better? Because we want the J here on the top part, the above this one, not the bottom side here. So better put it negative J over omega C, something like this. Just memorize this one. Okay, for those who miss or skip the derivation part, you can go through back that thing. Do not skip anything. If voltage V equal to 6 cos is applied to, do you want to do this? Or I give you as a homework? Homework lah. What time is now? Oh, we still have time. Okay. Okay, this part, impedance and admittance. Yes, they use basically coming from Ohm's law. Ohm's law is V equal to IR, right? So you have this impedance. Impedance usually they write in terms of Z. I think you already come across in physics class. And then it's a ratio of the phasor voltage V to the current. So V equal to I of this impedance. And then this impedance always written, the unit is in ohms. But for admittance, this is inverse of the impedance. So it is a reciprocal of impedance. So you have a impedance equal to 1 over R. Betul ni? Bukan. Y of 1 over impedance. Betul. So the unit is in Miho or Siemens. Okay, these two. And then if you want to write down in terms of real part and this is imaginary part, then this is impedance. Impedance always have real part and imaginary part. R plus JS, right? And then if you want to write down in terms of admittance, this one, you have a G. G is a real part and B is the imaginary part. What is a G? G is a conductance. G conductance and B is a susceptance. Sometimes if you have a MCQ question, they will ask you what is the G, what is a B, what is a Y, and then what is S. You need to familiarize with that. Or sometimes the question asks you what is the conductance for this question. What is the susceptance of this question? So you need to know which and which. Okay, but you need to understand that they have it in real axis and imaginary axis. Is it clear? The question kan tadi. Okay, jap tengok kau ada questions. Tak ada. Alright, very good. I'm sorry. I'm taking your time, your 1.5 hour direct for video. It's not supposed to be like this. All of us will be in pressure. RJ, okay, this one I think, okay, done. This one clear, right? Under DC condition, if you pull this one apart, you will get a short circuit, right? So under DC, you will have a short circuit. But for high frequency, there are different treatment. But do not worry on this. You just keep on this part. Your level is this, but they need to equip your knowledge with this part. High frequency, the inductance will become something like open circuit. Okay, for capacitor, if you pull these two apart, these two ends apart, you will have a open circuit. And impedance for capacitor is equal to, still remember? Equal to negative J over omega C. Okay, please remember this. Okay, done. This part, for this part, I think I have given you, if when you look any figure, you need to check whether you have a storage energy or what are they? Any guess? What is the storage
Capacitor.
energy elements? Okay,
Capacitor.
lagi?
Inductor.
Yeah. What about resistor?
I'm sorry?
What about resistor? Are
Not
they?
as
No.
much.
No, right? Not a storage energy element. Okay. If you look at the circuit, any circuit, if you have the energy storage element, then you need to straight away look at the voltage or the current source. Okay, look at the power supply. What is it? Is it in the DC or is it in AC? If you have it in DC, then straight away you know that inductor becomes a short circuit, and then capacitor becomes a open circuit. Since this one is a AC, how do you know? You can convert it into polar form. You have the 5 and then you have the theta, 5 with 0 degree, right? So basically you can use the normal rules here and then you can answer the question. But before that, you need to also know that you have the impedance for inductor. Okay. Okay. Do you have any question here? I think this one just the normal one. Please go through the video. Okay. Before this part, I think better we discuss on this. They give you angular frequency of 10 radian per second, and then they give you in terms of capacitor and inductor without the voltage supply. If you look at here, this is in farad, right? This is in Henry. Okay, farad and Henry. And in order to solve this type of question, you need to make sure all units here are same, and then you can plus or minus. So when everything is in ohms, then you can apply the Ohm's law. Ohm's law. Bukan yang voltage equal to IR. What I mean is Ohm's law for resistor in series, you can add, right? You can add. Resistor in parallel, you can do what? You can use inverse, right? The inverse. The inverse of these two. Resistor 1 and resistor 2. And then that's all I think. And then you can use a voltage divider and current divider for resistor. Still remember, right? I hope you still remember. Jangan makan lemang banyak sangat. Okay, so how to convert this into inductor? What is impedance of L inductor?
J omega in L.
L, yes. Okay, so J 10 with L 2. So this is J20. All right, and what is this unit? What is the unit for impedance?
Henry.
Ohm.
Impedance, yes, ohms. Okay, already ohms. So you know that this one equal to J20 ohms. You can plus with this 50 ohms. What is this plus this? And remember that you need to solve they ask you impedance of this from the input A, from the A and B input here. Then you need to solve furthest away from the terminals, right? So you need to take care of these two first. So this is 50 plus J20, right? Real axis and imaginary. Do you agree or not? This part?
Yes.
Agree.
Okay, good. What about capacitor? Equal to what? Impedance of capacitor equal to?
Negative J.
J
Over?
over omega C.
Omegas.
Okay, good. So negative J divided by 2 into 4 milli. And what do you get? Negative J. Apa ni eh? This is 8 milli. 1 over 8. What do you have? Alamak, I don't have. Oops.
Madam,
Inverse of it. Yes.
is it 2 or 10?
10? Oh, 10. Betul. Thank you. Okay, good. Saya letak 2 eh. Oh, I thought this one. I think I follow that. Okay, good. Okay, 10. So, mudah sikit lah. 40. 1 over 40, you have what? This is negative J. 25, right? And what is the unit?
Ohms.
Ohms, okay. So, this part, this and these are in parallel, right? This and these are in parallel. So how do we do this? This and negative J25. You use parallel rules, right? Okay, what do you get? Using your calculator, what do you get these two if you use parallel rules? Remember to use bracket. Negative J25 in bracket inverse plus 50 plus J20 and inverse. And inverse all the answer. What do you get?
12.38 minus 23.76 J.
J?
Negative 23.76.
Let's see. All of you get the same answer? Yes, right. Ke saya syok sendiri. Okay, this part. You have negative J over omega 10, then 2 milli. So you have berapa ni? Negative J 20, right? Betul ke? Capacitor. Ni berapa? 50.
Negative 50.
Ohms, right? So these two, they can be added. So 20 minus J50. And since we have everything here on the right, let me change the color. The right side here is this equal to this. Then you can, because they are in series with this, you can add together. So please add 20 minus J50. So 20 plus 12.38, you will get 32.38, right? And then 50 minus 23.76, you get this negative J73.76. Okay. For impedance, always write down in terms of rectangular form because you want the real part and also imaginary part. This is clear, right? Ke pening? Hari ni you going to have laju sikit lah. Real axis and imaginary. Any question? Because I dah explain dalam video. Did I explain this in the video or not? Any question? Semua diam ni, takut saya.
Oh, madam,
Ke dah-
no.
No, okay. Alright. Okay, very good. I think that's all lah. Do you want a pop quiz?
Yes.
Yes, Masya Allah. Saya tak plan anything. I didn't plan anything.
No.
No. Difficult.
No.
This is very difficult. Okay, jap. Okay, did I discuss this in the last part or not? The video. Can you try this? I think this is easy because everything is in ohms. If you look at the capacitor and inductor, try use your calculator. Do you get the same answer? This is the last. And then we end the class. Because sebenarnya dah habis time. Let me check the time. Oh, 2 more minutes. It's supposed to be finished. Finish. Then. Do you want to try at home? You're already at home. Inshallah. Done, eh? Okay. All right. I think you guys are tired. Okay. We finish our class with Tasbih Kafara and Surah Al-As. سبحانك اللهم وبحمدك أشهد أن لا إله إلا أنت أستغفرك وأتوب إليك. العصر إن الإنسان لفي خسر إلا الذين آمنوا وعملوا الصالحات وتواصوا بالحق وتواصوا بالصبر والحمد لله رب العالمين. Let me take your attendance first. But I didn't give you any task, so maybe difficult for me to check your attendance. Who here infected by COVID? Anyone? Or maybe your family members?
My neighbors.
Your neighbor? Oh, mashallah.
I have like 30 cases around my neighborhood within 1 kilometer radius.
Allahu Akbar. Are you in Selangor?
Yeah.
Oh, wow. I hope you stay at home. But if you need to go outside, then you use the mask, everything lah. Go, yeah. Today the virus spread very quick. It's not like previous virus. This is a new variant, so you need to wear something. If you don't use glasses, then you use shield, a face shield or something. Okay, try not to please avoid to go outside without necessary things. Okay, I hope we pray for the COVID to solve, and then also for Palestine, inshallah. Right. With that, Assalamualaikum. Dan subhanakallahumma.
Salam. Thank you, madam.
Okay, Assalamualaikum.
Tidak.